Guna, sir, you may proceed.
Hi, thank you, Asif. Good morning, everyone. I'd like to give you a warm welcome to the first DoT-TSDSI micro workshop series organized jointly by TSDSI and DoT. The first time we are doing this, so we are quite excited. And we have a very impressive lineup of speakers for this session today. And without further ado, let's just go to the next slide. It's my extreme pleasure to introduce my good friend Dr. Samar Shailendra from Intel. He's also the chair of the roadmaps committee in TSDSI. He's a senior standards architect at Intel and leads all the 3GPP related activities for Intel India to 3GPP, particularly in SA6. And on top of that, he's also working as a visiting professor to IIIT Bangalore. And as I said, he's also the co-chair of the TSDSI Roadmap Committee and the vice chair of the TSDSI Study Group Networks. So he's going to be anchoring the presentation today, and I'm going to let Samar take it away. Thank you. Samar, please go ahead.
Yeah, thank you very much. Sorry, I was on mute. Welcome everyone. Thank you very much, Guna, for introducing me with the nice words. I hope I can meet up all your expectations. Welcome all the audience to these micro workshops. A strange name, as it says, micro workshops, because this is very fast and furious in itself. It's very less engaging. You know, in the world, in the times of 2020, we are moving to the micro workshops from the workshops. So the agenda for today's, we have our wireless advisor, Mr. Christopher, to provide the opening remarks. He's a well-known person. We'll follow up with the introduction about 3GPP, which I'll myself touch upon. Then we have the most important part, or the technical part of it, is these technical study items about the Release 19 studies, where we have the expert panel who will be introducing all these study items, what are the requirements, what are the use cases which are happening in 3GPP, which are going to lay the foundation for the future network, which is 5G advanced and 6G. Followed by certain polls which will capture your interest about the workshop, the studies. So please do participate in that, because that will enable us to further reach out to you. If time permits, we'll have a small Q&A to answer very quick questions. As I said, it's not a full-fledged workshop, it's a micro workshop. So we'll have everything micro here. Followed by the concluding remarks from my co-chair, Mr. Deendayal Toshniwal, who is also a veteran and the DDG at DoT, who will be providing these remarks. So the entire motivation for this workshop is to introduce the people to the 3GPP, the requirements and the use cases of 3GPP, so that they can contribute, and we'll follow it up further with the more details as we progress through the workshops. So let me take this opportunity to introduce our guest speaker, Mr. Vijay Christopher, who is the WMO since 1991, and he has been very active and well known in the Indian ecosystem. Currently, he is the wireless advisor at WPC, Wireless Planning Commission, and he has the plethora of experience with respect to the spectrum and various aspects of the spectrum management, and he's a go-to person if you really want to operate in India. He has played various roles related to the spectrum auction, which has happened in 2016. So with that, I'll hand it over to Mr. Christopher to provide his opening remarks.
Thank you, Samar, for your kind words. Am I audible?
Yes, sir.
Okay. A very good morning to all the participants to this workshop conducted by TSDSI. At the outset, let me express my gratitude to TSDSI for inviting me to this session. I am honored and excited to open this series of workshops. India is on the verge of an accelerated growth on all fronts. Telecommunication has proved to be a significant growth engine. We also stand higher in terms of the total number of subscribers worldwide. That is very well known. But we are still lagging behind developed nations on taking a leadership position in defining the standards for next generation telecom related technologies. Now India has entered a stage where it has become important for India to take the challenge of creating our own standards or leading from the front for standardization. Standardization can help in achieving the self-reliance in technology development, besides fulfilling the mission of government, such as design in India, make in India, manufacturing in India, and thus contributing overall to the economy of the nation and achieving the dream of transforming ourselves from a developing nation to a developed nation. The 6G will definitely play a part in this whole process. The name of these workshops rightly encapsulates the spirit, advancing 5G towards 6G. That shows a progression from 5G through 5G advanced and into the 6G. It is interesting to know that Western countries are looking to India to take the lead in the technologies in view of the new geopolitical scenario evolving in the world. 6G offers we have immense potential and challenges at the same time. We need to work cohesively to provide a world-class 6G systems in the mobile technologies. It is also said that this decade belongs to countries like us. In such favorable conditions, the role of entities like TSDSI are vital, that this opportunity should not slip away this time. The recent experience of the standardization work pivoted by TSDSI in the 3GPP forum, supported by the academia, industry, and the government, should encourage them to go far in this mission. At the same time, we should not go overboard. Some reality check shows that we only make up 0.4% of the total 3GPP contributions last year. How we can improve this situation? That is the question of the day we should be asking. Standardization work has now taken the center stage in India, and we strongly believe that this is an essential pillar towards taking India to a $5 trillion economy as envisioned by our Honorable Prime Minister. I would like to share that TSDSI is working on this aspect from many different fronts, including collaborating with the government on providing grants to research linked to standardization work and providing subsidies towards expenses related to this work. In today's workshop, you're going to hear details of several work items under progress at 3GPP from several leading industry experts. The work item fall under general category of mobile network services, and they cover topics such as energy efficiency, satellite services, roaming related services, and network sharing. In this scenario, I also should mention that radio spectrum plays an important part in this process. It is the raw material and the resource that is needed to start the framework. Identifying the suitable spectrum, harmonizing with the technological advances, and reforming the existing users are all some of the challenges that government faces today in this process. WPC Wing is in constant dialogue with the stakeholders, including the industries and associations, towards facilitating and supporting the pre-standardization process at ITU-R, as well as the subsequent standardization activities where organizations like TSDSI would be contributing to the 3GPP outcomes. The standardization can help in adoption of a new technology on a harmonized way, thus eliminating the presence of multiple incompatible versions which can kill its growth. Standardization can also bring dividends in the form of flexibility, evolution of new products, and focusing on the customer's needs. At the same time, there are some pitfalls, negative impacts also, as the attention can soon shift to the price factor rather than adding features, because features are already taken care by the standardization. It can also rule out alternate technologies when the standardization encourages a uniform technology, perhaps as our experience with 5G teaches us. The goal for today's workshop is to provide listeners with a good overview of current technical activities in 3GPP related to release 19 and a quick overview of the process involved in making contribution. Doing so, we are hoping that more will join in this important work to help our great nation to go to the next level. I wish all success to TSDSI in formulating these workshops while creating awareness and sharing knowledge to benefit all the participants through this series of workshops. And I hope this will act as an invitation to encourage more to join in their efforts. Thank you very much.
Thank you, sir. Thank you very much for your encouraging words and expressing your interest for India to take lead. And I cannot agree more that Spectrum is the raw material on which the entire telecom system runs upon. So it's an important play, it's an important place, and yes, the world is looking at us that how we can leapfrog and contribute more and more in the entire ecosystem of standards and contributions. Thank you very much once again, sir. So with that, I'll move to the next item for today, which is about the 3GPP overview and a quick highlights into the release 19 timelines. I'll be presenting it myself. I would like to start by saying that there are some of us who are not very exposed to 3GPP, while there are many who would be knowing about 3GPP a lot. So I will just run through it so that we at least have a quick overview where is TSDSI placed with respect to 3GPP, what are the kind of processes exist, and a quick snapshot in the release 19 timeline. And I will also briefly touch upon that what TSDSI and the roadmap committee is doing for the Indian ecosystem align itself towards the release 19 contributions and going forward. And I would like to say that DoT has helped us a lot. They have committed towards our to increase our participation in 3GPP, to increase the entire Indian ecosystem to participate in 3GPP. And we appreciate if everybody could leverage upon all those nuts and bolts which has been laid by DoT to be used to create and develop this entire standardization ecosystem. So with that, I'll go to the highlight. So this is the 3GPP ecosystem. This slide talks about it. So it basically has the organizational partners. So across the world, we have 7 different countries who are the organizational partners or the SDOs, which constitutes the entire 3GPP. From these organizational partners, the companies, the labs, the organizations can become the individual members and contribute to 3GPP. The other ecosystem consists of the market representative partners like COAI in India, who also provides the market requirements to 3GPP to create the standards and the technology. And of course, there is a lot of other bodies which contributes to 3GPP, which participate with 3GPP through the license like GCF, 5GA, etc., etc., etc. The 7 organizational partners are like this: the ARAB, from Japan, the ATIS from USA, CCSA from China, HC from Europe, TSDSI from India, TTA from Korea, and Japan has another SDO as OP, which is TTC. So you can see that we are in a very strong position in 3GPP, and we should leverage that and contribute as much as we can. 3GPP, if you look at it, it has a 23+ old organization, starting from 2G, 3G, 4G, and now 5G. And I'm sure In another decade, we will have 6G, followed by so many Gs to come. So there is no stopping by. Once you are involved in the ecosystem, you have the entire world open to you. There are a huge number of specifications which get generated out of it. There are already 10,000 active technical specifications for all releases. If you participate in TSDSI, you will realize that the transposition of 3GPP standards in itself is a big task. That shows that, yes, this is a very, very active community. A lot of member companies, 750 plus individuals member companies are there, and almost 2,000 plus man years in cumulative meeting time has already been invested in 3GPP. That shows the grandness of 3GPP and the ecosystem in itself. Looking at the individual members, which is an interesting concept. So every organizational partner can contribute only through an individual member. That means that if an organization or individual has to contribute to 3GPP, they have to go through 3GTSDSI in case of India, become the individual member in 3GPP and start participating. So all those entries which are registered with the TSDSI or any organizational partner for that matter is eligible to become the individual member at 3GPP. So what they get out of it is they can contribute technically, or they can even become a part of the technical specification group to influence the entire 3GPP ecosystem. You can use the 3GPP results, and you can do the voting rights. You can, participate in creation of this ecosystem of technical standards. A very quick glimpse into the 3GPP organizations for somebody who is not aware. So this is coordinated by the project coordination group, which is like the governing body of 3GPP. Furthermore, it is divided into three different groups. One is the TSG RAN, or the Technical Specification Group on Radio Access Network, which takes care of all the RAN related aspects. Then you have the service and systems aspect, TSG-SA, popularly called the SA group. And then you have the CT group, so core and network and terminals. So each one of them is divided into certain working groups, which focuses on certain aspects of those particular group. For example, if you look at the RAN group, the RAN TSG, it has got 6 different working groups: RAN 1, 2, 3, 4, 5, 6. RAN 1 focuses on the layer 1 aspects, while RAN 2 will focus on the layer 2 and the RR aspects. RAN 3 will talk about the ONM requirements, interfaces, and so on and so forth. Similarly, if you look at the SA, the SA1 basically generates the requirements, and that's the group which is of our interest today, because for every group to work, the first step is to generate the requirements, and SA1 plays the lead role here. So for release 19, which is the upcoming release, SA1 is already working on the requirements for that, and we are in a state where we are very close to the closing of these particular requirements. So we today will look at these SA1 requirements. All our experts will present related to the mobile network and services today, followed by the other 2 workshops which will be happening the next week and the subsequent week. And at this point, I encourage all of you to register for those workshops as well. Please don't miss the opportunity. Moving forward, if we look at the entire standardization process, it's, as I was just mentioning on the previous slide, it encompasses 4 stages. The first one is the requirement, which we will be talking about today, and SA1 works primarily on that. Then we come to the stage 2, which is more on the architecture side, where SA6, SA5, SA2, and other groups work on. So this is from the core network point of view. Similarly, the RAN groups also work on the radio specifications. Followed by, it moves to the stage 3, which is the protocol development stage, or we call it the normative stage as well. The stage 3 is the stage where you are generating all the protocols and specifications for all the work which has happened in the stage 2. And in that stage, the CT group works upon it and takes the specifications out. and will become usable by the external bodies and the entities. And finally, we move to the stage 4, where it's more about the development of the specifications, conformance testings, etc., etc. Okay, so this is where TSDSI is trying to gear up the Indian ecosystem to contribute to the release 19. So as you can see, the top part of this figure is talking about what are the 3GPP timelines with respect to the release 19 work. The work has already started. For that matter, SA1 is already gearing up all the requirements and creating these specifications for the work to be taken up by the other groups. The way it works is it starts with a study phase. Somewhere in the March, the study completion will happen. This is the place where we are targeting to contribute from India. So if you are interested, if you find that, okay, this is the technology I want to work upon, you go back to 3GPP and put your requirements into the SA1 requirement ecosystem, which will be followed by the workshop, which was earlier planned in March, but it has now moved to the June time frame. In the last planner date has been decided, so we got a little extra time to work on the requirements, which will, in this particular workshop, the content for the entire release 19 will be frozen. So we have to work towards this. We have to, work to prioritize our requirements and go to this workshop and make sure that our particular contents have been presented and discussed properly, followed by the package approval, which was earlier supposed to happen in June. Now it will move to the September. So the package approval is the time where the content which needs to be studied and specifications to be created is finalized. So for SA group or the core group, this will be done in September, and for the RAN group, it will happen in December. So this is the time when your entire release got frozen. Now there will not be any change which will be incorporated after it. To facilitate all these contributions, TSDSI Roadmap Committee is organizing 3 workshops, which is workshop 1, 2, and 3, with the first one is in this list. Followed by, we'll have something called a TRIP forum. TRIP is the Technical Roadmap Item Proposal Forum, which will be discussing all these contributions to this SA1. So we will start with the release 19 content discussions, the workshop inputs, the package inputs, etc. And from a roadmap point of view, this release 19 work will be completed as and when your package approval is finalized. And then we will start discussing the release 20 study items. So this is how the entire roadmap committee is placed. In parallel, we have the study group, which continuously keep on discussing the standardization items and contribute to 3GPP and so on. As a next step, I would say, to contribute to the release 19, join the TRIP forum. It does not really require any membership. We have an expression of interest form, which will be shared towards the end of this workshop. Please fill that form, or you can also reach out to Mr. Preetham Bishnoi, who is the advisor at TSDSI and helping us in promoting the 3GPP and contribution there. If you want to contribute to 3GPP directly, yes, you can join it through 3GPP through TSDSI. You can acquire the individual membership. There is a certain process which needs to be followed, like creating an EOL account, HC online account, look at the working procedure, identify the topic of interest, and start contributing to these work groups. This is fairly straightforward. Towards the end, I would say we'll have some certain poll questions coming towards the end of the workshop to identify your interest and to help you progress with the contribution to the 3GPP. We'll have the expression of interest form, so that will also be shared at the end of the micro workshop. Please take some time to fill that up. If you have any queries or you need any information, please reach out to General Lieutenant Pritam Bishnoi. And we have 2 more workshops coming up next week and subsequent week. Please don't forget to register for them for more insights into this study. So these are some of the important links which you can refer. We'll share out all these slides to you so you can refer to them. Thank you very much. If you have any questions, please hold it on. We will take it up towards the end. And with that, I will move out to the second session, where I would like to invite Mr. Vinay Srivastav, who is the General Manager in Reliance Jio, a very good friend of mine and a very established person in the industry, a very well-renowned contributor to 3GPP, ITUR, etc. He has some of his notable contributions include the NAVIC standards, and he is fairly active on 6G as well. He has been the rapporteur of 6G use cases, requirements, and technologies at TSDSI, which has been contributed to ITUR. He has championed the spectrum studies towards ITUR and quite some experience in this area. So over to you, Mr. Vinay. Akash, can you please help to pass on the...
I hope I'm audible.
Yes, Vinay, you are audible. Can you control the slides?
I think so, yes. Good morning, Mr. Christopher Samarji. Thank you for that lovely introduction. And a very good morning to all the audience who have come along here in this TSDSI DoT micro workshop session. I would this morning, try to bring the audience through one of the important study items in release 19, which comes under the purview of the network and services, and the name of the item is energy efficiency as a criteria, as a service criteria. Right now, I would try to give the background, the motivation behind the study. We will also see what is the background work which has already been done in 3GPP, and then we will see what, how and what is the motivation of the current study which is ongoing in release 19. Right now, the global energy shortage and the climate change, these are the issues that require international cooperation and coordinated solutions, at all the levels. Many regions, countries have published policies, and requirements which are, which are aligned towards the control of carbon release, and they're trying to promote the energy efficiency in their geographies. India has also committed to some, SDGs promoted by United Nations. Now, these policies have made energy efficiency a strategic priority for many telecom operators around the world. Network energy saving is of great importance, right, for the environment sustainability, to reduce environmental impact on greenhouse gas emissions, and even for the OPEX reduction in MNO's perspective. Right now, as 5G is becoming a pervasive technology across industries and geographical areas, handling such kind of more advanced services which are coming in 5G NR support, and the kind of applications, they require high data rates. Right, the network has become more denser. There are more antennas everywhere. Larger chunk of bandwidths are being utilized, and more frequency bands have been identified. Now, with all this in perspective, the environmental impact of 5G needs to stay under control, and novel solutions to improve the network energy savings need to be developed. Right, so moving on to the next slide. Yeah. Now, this particular slide, gives a perspective of energy consumption under an operator's purview, right? The way the energy is distributed, and as we see here, the energy consumption is a key part of our MNO's OPEX. Now, this diagram is in sync with a report from GSMA towards the energy cost on mobile networks, right? So mobile networks account for around 23-25% of the total cost which an operator encompasses. And within this network cost, the RAN part, right, the radio access here, if you see in the middle, RAN sites, they are the ones which constitute 73% of the carbon emission. Now, and hence it becomes very important to look at ways and means of not just controlling or reducing the energy being utilized here, but also a means to provide a visibility to the outer applications and the policy makers to see which kind of applications and which kind of subscriptions cause how much of energy consumption, right? Now, power consumption of a radio access can be split in two forms. One is the dynamic part, which is only consumed when the data transmission or reception is actually ongoing. However, there is also a static part, right, which is the energy which is consumed all the time, right, just to maintain the necessary operation of the radio access devices, even when the data transmission reception is not ongoing. So I think the second part is the one which was targeted first, obviously, because the standing or the static part of the broadcast system of the essential common channels is something which should be minimal, right? And hence, compared to 4G, 5G is a much leaner technology by design, right? So 5G basically allows us to have common channels with beamforming. They are not always on, right? So these kind, and even the TTIs have various options. So they allow a lot of energy saving by design itself. Do we need more energy saving? Yes, is the answer. How and where is something which 3GPP went in to look after, right? And as I already talked about, right, in 2016, the MNOs or the mobile industry was the first sector which actually committed to the UN 17 Sustainable Development Goals, and different MNOs have laid out their their carbon neutrality dates in future, and they are all working towards it. Standardization forms a base which provides them the means to do that, right, in the larger context. Let's move to the next slide. Okay. Yeah, I'm sorry, I think, yeah. So now energy efficiency has been considered in many standard groups and specifications already. ITSI, GSMA, and have already specified, a lot of requirements from industry perspective. ITSI has defined specifications to encompass the measure of the KPIs for energy efficiency, and 3GPP has also tried to adopt the same in a generalized fashion. 3GPP started working towards energy efficiency more actively in release 18. However, as part of management and orchestration work, right, O&M specifications, as we call it, under the task systems aspect, task group 5, this has already been a inherent part. Their O&M always tries to measure the energy encompassed by the network for different services and aspects. However, when 3GPP started specifying 5G advanced features, that is from release 18 onwards, the SA group, the TSDSI requested, and it also provided a guidance to all other working groups and TSGs to consider energy efficiency even as a guiding principle when developing new solutions and evolving to the 3GPP system specifications, apart from already established principles which 3GPP system design considers, right? And then 5G NR having the capability of the slice implement, or the implementation of slicing, right, which is basically on the same principles of virtualization across the entire network. It provided the baseline to enable this. Now, if you see here, in release 18, the energy efficiency related work has happened at 3 groups: SA1, SA5, and RAN, right? So RAN, if from the previous slides which Samar went through, if you try to correlate, SA5 and RAN come in stage 3. However, SA is the one which which identifies the use cases and specifies the requirements and guides the basic motivation towards accomplishing this. So this is where it all starts, right? So SA studied the system requirements as required, right, to provide a control framework for energy efficiency. SA5 is basically looks at the management and orchestration specification, and hence is also the charging, and hence it's the primary location where the specification and the KPIs and the model of charging with respect to energy efficiency were first considered. RAN, of course, is the radio access network part where most of the protocols run, the lower layer protocols, and they are very closely associated with the major power consumption. And hence here the study focused on the energy consumption models. They evaluated different methodologies, taking different KPIs into perspective, and then they published their recommendations. We'll see more about this in the next slide. Now, yeah, so just to give further insight into the work which SA did, right, these are the technical specifications which SA5 published, and the summary of each. It needs to be identified that while doing this work, as 3GPP was in constant liaison with its NFV and NFV Mano, right, to obtain more accurate virtual CPU usage measurements, and to define measurement with the perfect accuracy. And they also tried to introduce additional metrics when estimating the energy consumption of these virtual machines, right? For example, the virtual disk, the link usage, and all. They also worked on extending the existing solutions to container-based network functions, CNFs, in addition to the VM-based virtual network functions. So the ones in audience who are familiar a bit with the core network difference between the earlier generations and 5Gs would probably identify that in 5G the core network function has become more software centric, and all the functionalities are now defined as network functions, which can rely which use the same technical aspects as when virtualizing on the task as NFV and CNFs. Now moving to the RAN part. Okay, so this is a quick snapshot of the KPIs, the KPI for the 3GPP energy efficiency, which has been defined, and it's a generalized adaptation of the recommendation from 8C towards the energy efficiency. In very generic terms, it's basically the performance which you get out of the network to the energy consumption to get this particular performance, right? And these are not very amicable terms as far as measurement is considered. So there is a lot of work which needs to be done to define the performance, right? It's not a very readily measurable criteria in all scenarios. And so there are SA5 specifications which capture this part of the performance, and then even the energy consumption is is equivalently if not vague, is difficult to capture, because the energy consumption happens across the network. Towards that, the ONM specifications mentioned here by SA5, they provide the guidance, right? In interest of time, I'll just move quickly to the RAN aspect. This is important because this is the study which RAN had undertaken and might form the basis of future work item in release 19 probably. The impetus of saving the network energy has grown remarkably, as the energy cost has become a significant part of the OPEX which MNOs bear. Now, besides these reductions in the network energy consumption, These are imperative for the operators to ultimately achieve the sustainability objective of net zero. Now, looking at the RAN aspect, 5G NR, is significantly more energy efficient in terms of energy consumption per bit to the previous generations, as I already said. Now, due to the increasingly dense network of 5G networks and use of technologies like massive MIMO, higher bandwidths, and for being able to support more frequency bands, 5G networks would lead to higher energy consumptions, even though the technology is much leaner compared to the previous generations, right? So proper energy saving measures need to be applied. And hence 3GPP approved a study item on network energy savings for NR in release 18, which has been highlighted here. The study aimed to define a network energy consumption model for the base station, to develop an evaluation methodology, and to identify the KPIs. Now, the study also investigated the techniques to improve network energy savings in targeted deployment scenarios. So it provided, it not only evaluated the potential network energy consumption gains, but also it assessed the balances and the impact on the network and user performance. So there will always be a trade-off between the energy saving. If you're trying to save energy, you will probably need to take a hit on the performance somewhere, and which ideally we don't want to do. But for all practical purposes, that is what will happen, and you need to assess the impact of each energy saving mode on the performance impact on the network and user. And these were evaluated in this study, right? And the various mechanisms were suggested, which I have tried to enlist here, right? These are all in perspective of RAN, and different methods, which are many of them, if not all, are closely related to the common channels, right? The optimization and the cycles of the common channels to ensure that the devices and even the networks at time gets bandwidth or scope to save energy by going to sleep, DRX, right? So now the network energy savings for NR was studied here, both for FDD and TDD, both for frequency ranges FR1 and FR2, which is millimeter wave. And this study discussed both kind of techniques, which were time domain as well as frequency domain techniques. As I already said, that potentially this particular study item will give rise to further work items in release 19. Moving to the next slide, which is the main agenda here, energy efficiency as a service criteria. The motivation, it's very important to understand what is the difference as compared to the previous work in 3GPP to this one. Now, energy efficiency specific efforts so far which 3GPP has taken have aimed mostly at improving the energy efficiency by impacting the operations of the systems. And the network works in silos. It's only the network which knows how much energy is being saved, where is it saving, and what it wants to do, right? So there is no way a policy could be enforced, right, for a particular kind of service from the perspective of a user. The user has no visibility into the kind of the kind of energy efficiency class his service falls into. So, and there is no way they can optimize, for example, their uses of network services if they have already committed to a criteria of greener tomorrow. Now, the existing studies concentrate more on how to satisfy user experience and try to achieve energy efficiency at the same time within the network. So the requirements, use cases, solutions, they're all basically within the network itself. The verticals and customers have no approach for this energy efficiency related information from the network. Now, introducing energy efficiency as a service will allow these users to have a choice, so that they can select proper energy efficiency criteria as well as other network performance parameters when they, for whatever reason they need it, right? As I said, policy can be one of the reasons which might force them to use. Now, currently energy utilization and efficiency can be monitored and considered, but that is only through the operation and maintenance, O&M, and the network operation. But but not as a service performance criteria. For example, the other performance criteria are bit rate, latency, availability, which are readily monitored and they are established KPIs. So this particular study item is towards identifying scenarios where and ways wherein this energy efficiency could be provided as a service to the external party from the network, right? Now let's start looking at the use cases which have been identified in this uh, study so far, right? So first use case is energy utilization as a performance criteria for best effort communication. Now this best effort communication is an important type of traffic where the energy efficiency policy, right? For example, the maximum amount of energy to be utilized could be applied without the conflict with its guidance. So best effort traffic is the type of traffic that provides the service to customers, where everything else being equal. So there is no QoS implication that the network needs to abide by certain latency or certain throughput. So this is the easiest form of communication which has been targeted first. This is the approach 3GPP takes. The first use case is for the most natural choices, low hanging fruits, if you want to call it. And once they have established the schema of things around such use cases, then they try to go, utilize the same generic schema to more challenging one in the future generations and future studies. So this particular use case which we are talking about, right, which falls under the best effort traffic, the idea is, for example, that there would be a collection of IoT devices, right? And if these all will be transmitting some reading, some data in the uplink, and based on the coverage of the network, at some point in time, for example, if they are moving, if they're moving across and they reach a region where the coverage is poor, then they would have to churn out more uplink power to be able to communicate the data to the network. Now at this point in time, it's IoT data and it's not latency critical, so you can trade off the latency with power, and the network can ask the device to stay put for a while till they reach back a good coverage area where the transmission can happen in in lesser power. For example, lesser number of retransmissions, for example, are required in uplink, and the uplink power is also less. And then once the U is stop transmitting an uplink, and once they are under a good coverage, they can then communicate back the buffered data to the network. So this is the kind of use case. That's the first use case which has been identified. Right?
Vinay sir, can we make
Yes.
it?
Yes, sure.
We are
So
already
okay. So the other one is supporting different energy efficiency modes in industrial campus. The industrial campuses are normally off limits from the city and they have dedicated networks only, which are working only for them. They are called private networks in many cases. Now the issue with this is that the industry or these campuses, they work at maximum throughput only during some peak hours of the day. The other time of the day they are actually not using that network, and the network can, if the proper SLA is defined between the network and these industries, then basically a lot of energy could be saved at the network end. The third one is the energy usage exposure considering possible deployment scenarios. This use case basically enables the user to get an estimate of the energy by irrespective of the distribution or the deployment of the network, actually, whether it's more concentrated towards the distributed units or the central. Fourth one is the energy usage information exposure under NP and RAN sharing. So just like the use case 2, 4, what happens is in many of the private networks, these networks readily use RAN sharing. We'll be talking about RAN sharing in one of the coming sessions. And there should be mechanisms where if it is not a dedicated network, even then, even in a sharing network, there are ways for the network to calculate the energy efficiency for the slice of resources which a particular user or a particular industry has used. And this particular use case aims to enable that. The last but most important from MNO's perspective is the service energy monitoring by an application server. So basically, as you see in this picture, there'll be a slice for user and a user device which would be talking to 5G network, and there'll be an application server, right, which would be connected to this 5G network through this device over internet, for example. And that this is what would be triggering different services, be it positioning or some other information. Now if you can provide the energy monitoring to this particular application server, various kind of policies could be enabled. For example, the ability for the network operators to create maximum energy credit policy, the ability for 5G systems to say calculate the energy credit use, the expiration of these credits, and so on, right? So this use case is towards that, how to convert the energy efficiency into credits, how to make an equivalent choice and policies so that energy efficiency is visible just and could be purchased, for example, and people are more aware of what energy efficiency impact they are causing. So I think in interest of time, I'll go quick. Towards 6G, how is this related to 6G? We as the IMT 2030's requirements, the vision and requirements are being freezed in their final stages at ITR IMT. Now, sustainability is being discussed as one of the 6G design imperative, and hence this is just a precursor, right? For example, this particular arena of energy efficiency falls into the sustainability pole and would give rise to many future work, which I have tried to capture in the next slide quickly, right? And these are some of the possible future arenas towards research for the academia, right? 6G, as you see here, has been envisioned to provide much larger network capacity using much lesser energy. And if you see at zero capacity, the standing low energy usage should be minimal, close to zero. And to achieve this, a lot of research is required. The standardization at 3GPP or any other body requires a lot of research backing for one to propose new things. And we invite both academia as well as startups who are working either in RAN areas or in the computer researchers working towards NFV and containers, who can associate and contribute to these, to come forward, start engaging, and see the potential towards contribution to the current or the future 3GPP release in the energy efficiency arena. Thank you very much. I'll pass on the control to the convener. Thank you.
Thank you, Vinay. Thank you very much. Thanks for very enlightening session. And I know these sessions are very engrossing, very interesting to talk about. And I see there is a lot of interest from the audience as well. So what I would suggest is that audience is already pasting certain questions. So Vinay, you can probably look at them and try to answer those questions. I'm not sure whether we'll be able to take up the questions towards the end because we are running slightly late. So without any much ado, I would like to introduce Jishnu, who is the principal architect with Tejas Networks. We know Tejas is the indigenous manufacturing company and very well-known and reputed company in the Indian ecosystem. He is very instrumental in TSDSI Cypress front-haul standard, which was, I believe, the first standard which TSDSI developed, indigenous standard, I must say. Very well known for the efforts which we had put in creating the radio interface technology, which is also called 5G IE in ITU, and that was the first step which India had taken, the TSDSI is taken for creating a global impact. So without further ado, I will hand it over to Jishnu for walking us through the study item.
Thank you, Samar. Thank you for the introduction. Thank you. So I am just discussing this topic, study on satellite access phase 3. This is basically from an essay perspective. So the work is related to release 19, which essay 1 has taken up. So I will give some brief introduction on what has happened in release 18, basically from a RAN side, and then explain what is happening in release 19 from an essay 1 perspective. Okay, so just to, I think there will be many participants who may not be very aware of the non-terrestrial network, how it works. So all of us use the dish TV, etc. So it has similar concept. So you use it basically for broadcast presently, and there is also now an option to use it for communication. Already there were satellite phones which were very quite common. So their terminology involves something called gateway. So it basically connects to the satellite, and the connection between the satellite, the gateway to the satellite is called the feeder link. And then from the satellite to the devices is called services link. The service link in turn actually consists of multiple beams. So the beam forming has been in use for quite some time in satellite domain. So what is different? Earlier it was mostly about geostationary satellite, which was used for communication and the broadcasting part of it. So now there are multiple other options which has come up, which is LEO, which is low Earth orbit, MEO, medium Earth orbit thing. So this is defined in what. So if you want to start off reading something, the right place would be to read up the TR38821. So this has been created over the last release 18-17 time frame. So this covers all the issues which are there related to the NT and non-terrestrial network. So they have classified it as LEO, MEO, GEO, and there is also a UAS platform including HAPS which comes in. And then there are highly elliptical orbits. So these are different considerations. So things are slightly different. For example, in LEO and MEO, the jitter is found to be higher. The latencies are lower. The GEO would be like you will have higher latency, and the jitter is not there because there is no change of satellite. So there are some slight differences between this, and things are slightly different from terrestrial network because your timing advances are different. Some of these cannot even use HAR. So these are the key changes which are there when you assume that the satellite, if you're going through a satellite rather than a terrestrial network. So how do we go about doing this? So there are two ways to do it. This is what is sort of standardized, like sort of recommended as part of this TR3821. One is the mechanism is called a transparent model. So you can see here that the gateway and the satellite comes in between the GNOD and UV. So we are actually doing an NR-UU transparent service. So the UU interface is being transparently carried. So that's called the transparent model. So it is recommended both for LEO and GEO satellite. The second model, which is called the regenerative model, here you can see the GNOD DU part would be as part of the satellite. The NG link will open over SRI. The SRI is the satellite radio interface. The satellite in turn can talk to each other, and that interface is called the inter-satellite link. So that's called the ISL link. So that can be basically all the XN interface can happen directly between satellite without coming through the gateway. So that interface is there, whereby the satellites can directly talk over the satellite link. And I think the devices already are there. The Apple recently announced a mechanism to connect to the satellite. So devices also, at least that is basically to send the SOS message. So the effort has been to at least provide some basic voice over IP communication. So that is the first use case type application which has been dealt in the initial releases. So what has happened till now in the release 18 has been there have been some IoT enhancements. So this is regarding the mobility. How do you handle mobility between, like if you have to transfer between satellite 1 to satellite 2, performance. All the assumption here is that the device will have GNSS. See, this is itself a big assumption for IoT device. IoT device may not. So this is an added cost and additional power requirement for IoT. So the release 19, the effort is basically to see if we can have devices without even having the GNSS inbuilt into it. So the effort in release 18 has been to say provide a better coverage. This is basically assuming that the terrestrial network is not there. How do I connect? Maybe can I connect over NTN and provide basic voice over IP capability? So this was done for class 3 devices, which is basically 23 dBm UE devices. So that was the effort which happened in RAN. So that's still ongoing in the RAN level in release 18. The second effort was towards ensuring that basically you can we use 10 gigahertz. So what is the main issue here? It is like 3GPP right now has been always assuming that anything above in the higher bands are all TDD mode of operation. So in 10 gigahertz, they are basically doing FDD mode of operation. So that is an additional thing which had to be brought in. And it can basically work with fixed and mobile VSAT terminal. So the fixed VSAT terminal is a well-known thing, but it was again with a proprietary technology which was being used. Now it will also come as a 3GPP technology. And you can even have mobile VSAT terminal. There was another thing which was network verified UE location. So this is something, some work has happened, but I'm not fully aware exactly where it stands. But this was part of the work item. I don't think much has happened towards that, but this is another thing which is actively being considered under release 18. Then there are issues between NTN and TN. So can I do some seamless handover? So there is a mechanism called conditional handover, which was built into the radio RAN layer as part of the 5G release 1780. So can I use a conditional handover? So whenever the signal quality is bad and there is no terrestrial network, can I hand it over to an NTN? So this was some issues which has been mentioned in detail in 38821. So you can go and spend some time understanding all of those issues. Other issues like cell reselection, handover enhancements, etc., are being considered. So the handover enhancement is about the CHO, which is the conditional handover. Cell reselection for power reduction. So power these are the issues which are already in the release 18, which is being discussed. So what's happening in release 19 is basically the store and forward operation. So can see the basic issue is that for any of the signal, you basically need a gateway. Otherwise, there is no way you can connect to the data network or the internet. So what happens if there is no feeder link? If the feeder link itself is missing for some period of time, what do you do? So that's the first issue which is being discussed, or at least being considered in release 9. Like this came up in the release 19 SA1 discussion. The second part, which I mentioned earlier also, that can we have devices, IoT devices, without GNSS being built into it? So this is the second item which is being discussed in detail. I will cover each of this in detail in subsequent slides. The third thing is that position enhancement for satellite access. So right now, all the position aspects, all the positioning KPIs are all related to the assumption that there is a terrestrial network available. So the KPI, some of the KPIs itself may be not possible to be met with satellite access. So if you are completely moving to a satellite-based positioning, how accurate can it be? It's not a GNSS thing. This is an enhancement to that positioning which needs to be done. The last one is can communication between UE happen without actually going through the satellite? Satellite adds an additional latency. So if you have a community of UE, say this assumption here is a group of ship in the sea which are going together, and if the ship have to communicate between each other, or the devices in the ship has to communicate with each other, is there some other mechanism other than the normal mechanism of going through the satellite? So the first one, the store and forward operation, is basically an autonomous. This is to allow basically autonomous operation of UE. So the idea here is that the satellite is not connected to the gateway, so it has some buffer. It can do some amount of operation directly from this. So this is roughly like the earlier term, the SMSC sort of getting integrated into the satellite. So this is relevant for this NGSO category, which is this low Earth orbit and MEO thing. So particularly relevant for the delay tolerant IoT. So basically, the idea here is the effort in the release 19 effort of SA1 is to identify service requirements associated with this capability, including related to how do you authorize the user, what is the contact status, etc. So this is the first item in release 19. The second thing is that how do I go have a devices without any GNSS capability? This is advantages in both way, in the sense you can reduce the power cost as well as the cost of the device as well. So applications which are being thought about is in the IoT, and other thing is like even in the border area, if you have to do a mobile like video surveillance and basic broadband communication for video surveillance without having the video camera itself doesn't have the capability to do the GNSS operation. So there are options for all of us to contribute towards providing more use cases, including some other applications. The third thing is about position enhancement. So you can see the release 16 position enhancement were basically targeted for terrestrial access. So you have all those measurements, whether it's AOA, angle of arrival, etc., which has been done purely from a terrestrial network perspective. So this can be extended for satellite. So this is the third item which is being discussed in release 19 SA1. So more use cases can be added. This is in a very initial stage. So beyond these two lines, there is nothing in the actual work, the study item, work item, which is being presented. So we'll have to see how does this evolve and what more gets added. The last one is quite an interesting use case where what happens if I have no terrestrial coverage and it's like a group of ships or car which basically are moving together. This is far away from the territorial or any terrestrial network and needs access through a satellite means. The issue here is like communications. If you have to go through the satellite, will be long delays and you have limited data rates. But if you have to communicate between the cars, can I have a peer-to-peer network which can communicate? Which is like, can I use some side links, etc., for those communication? So this would need some coordination. So this is especially useful for all those mission critical services, V2X type use cases. And then, so this is basically the first assumption here is that it is all within the same satellite coverage. So there is, the requirement is for a low latency requirement. So this is the use case on which it is working on. And this would cover sort of all the use cases which needs like uplink and downlink and with lower latency. So all these things are under discussion. So we'll see how it evolves. So I would sort of also recommend everyone who is interested in this topic to start reading 38821 and then start working in 3GPP to provide more inputs around that. So it's a good starting point. At least that's where I sort of started reading it up. So, and hopefully I would see a lot of you contributing towards this in coming meetings. So thank you for giving me the opportunity, Samar and team TSDSI and DoT, for this wonderful opportunity to give this talk. Over to Samar.
Yeah, thank you, Jishnu. Thank you very much. As we see that satellites is a very hot topic in 3GPP, and we are already running the phase 3 of it. But nevertheless, we still have great opportunity to contribute to this. A lot of requirements are still in place to be created, to be built, and to be executed. So gear up, buckle up yourself and contribute to 3GPP. This is the right time to get your requirements and standards in place. So without much ado, I'll move up to the next two presentations, which will be taken by Mr. Mahesh Naika Masoor Anaya. He is the Assistant Vice President in Reliance Jio, and he's a very great friend of mine, and he's also the study group chair of SDSS, which is the Services and Solutions. And you know, in spite of not keeping well in last couple of days, he agreed to deliver this presentation, which shows that how dedicated and committed he is to make this towards TSDSI, towards the study group, and towards all of us. So with that, over to you, Mahesh.
Thank you, Samar. Thank you, everybody. First of all, good afternoon, everybody. And this is Mahesh. And today I'm going to take the session on value-added services, in particular to the roaming scenarios. Basically, value-added services.
Just a small interruption. We are running slightly behind time, so if you can help us with keeping it up.
Yeah, I'll try my level best. Okay, so see, when value-added services is already well understood by the industry, well deployed, and well utilized to generate the revenues by various ecosystems, then why again this guy is talking about value-added services? So this question may be there in your mind. So let me try to uncover the reasons. So actually this particular slide is talking about the 5G system architecture from the roaming scenarios. And if you see the visited PLMN and the home PLMN, they are going to communicate with interconnected interfaces like N32 and N9. So N32 is the interface which is used, which is the inter PLMN interface, which is used to exchange the control plane related informations. And this N32 is going to be security enforced by security edge protection proxy kind of functional entities. This is a new entity which has been introduced in 5G, and going forward this N32 interface will be security enabled. Similarly, the N9 interface is the user plane interface, interplane user plane interface basically, and this IP UPS, that is inter PLMN user plane security, is a functionality within the user plane function which enforces the security even on user plane data as well as the signaling associated with it. So because of this security enforcement across inter PLMN interfaces, then the value added services which needs to be supported for roaming scenarios across this N32 and N9 is one of the reason to restart the study on some of the value added services. Next slide, please. Yeah, see, basically, if you see right from 2G till 4G, there was no confidentiality or integrity protection across the inter PLMN interfaces. And as such, all the value-added services from the roaming perspective, therefore, realized without any hiccups up to 4G network. But in 5G, because end-to-end related security requirements has been brought in, we may have to revisit some of the changes that needs to be done for roaming related value-added services. So that is why from in 5G, we need to revisit the roaming related value-added service. Next slide, please. And because of this, in this particular study, we have considered 3 different use cases, that is welcome SMS and steering of roaming during the registration procedure, and subscription based routing to a particular core network. So these are the 3 use cases which has been considered under this study as part of the release 19 study item within SA1 of 3GPP. Next slide, please. So with respect to the welcome SMS, I think it is everybody is very clear about what is welcome SMS. See, whenever we move from Bangalore to Delhi or to any state to any state, the moment we come out of the airplane mode, the first SMS what we will receive is welcome SMS, which indicates you are in which state and you are under which network and what are all the services you may get. And this indirectly indicates that you are going to be charged differently because of the roaming aspects coming into the picture. So this is known, this is well known. But this is known because it is circle to circle. Every operator has got a different circles, like Karnataka circle, Delhi circle, Andhra circle, etc., etc. So different circle has got different charging aspects, etc. Maybe free also in some scenarios. But in case of international kind of roaming scenarios, that means one PLMN of one country to a different PLMN of different country. In this particular scenario, this is very critical, like charging aspects. Then the inter PLMN connectivity needs to be secured because of a lot of threads that may come. So because of these kind of threats, I think from 5G onwards, this particular link is since it is being secured. So welcome SMS also need the information exchange across the inter PLMN interfaces needs to be revisited, and if there is any gaps exist, then those gaps needs to be identified as a new set of requirements to support this welcome SMS as a new service. Next slide, please. See, actually, potential requirement that may come because of this welcome SMS is something like this. The 5G system shall be able to support mechanisms for the home PLMN to provide a notification, including equipment and subscription identifiers, to a trusted application server when a UE successfully registers in a visited PLMN. In response to the notification, the trusted application server can indicate specific actions to the home PLMN. See, this requirement looks very normal and it is achievable. The only thing is across the interface, if there is any specific requirement, those things has to be addressed. Otherwise, the service as is not going to change. Next slide, please. Next slide is next use case is basically on steering of roaming. Basically, in this particular diagram, if I have mentioned the sequence numbers, so let's go in that order. So the first is the UEX and UEY is basically is a residence of geography 1, and they are going to roam towards geography 2. When they come to the geography 2, basically they will sense the signals from two operators. Let's say mobile network operator 2 and 3, which becomes the visited PLMN 1 and 2 for these users. So when they come out of the airplane mode, when they land onto the geography 2, they will try to initiate the registration attempts, which indicated in number 2. So they both users will send a registration attempt to the visited PLMN 1, because they have selected visited PLMN based on the priority according to their current configuration. So both registration attempts reaches the visited PLMN, and since there is no subscription exist for these two users in visited PLMN 1, the registration attempts will be forwarded to the home PLMN, and in home PLMN there is a new functionality called steering functionality has been enabled, will be enabled, and which will detect, which will process and considers which UE should be processed in which PLMN. So in this particular example, let's say UEX will be processed under visited PLMN 1, but UEY no. There is no, the decision will be no for UEY. So for UEY, the steering decision entity will reject, and the registration reject will be sent to the UEY back. So UEY naturally selects the next available PLMN, that is visited PLMN 2, and the sequence continues. So basically, this steering function in the home PLMN helps to basically to decide which user should be processed under which visited PLMN, and also it will help to balance the load across the multiple PLMNs. So these kind of use cases also will be considered under this study. Next slide, please. So because of this kind of use case, there are two probable or potential requirements that is going to become. That is potential notification, including subscription and equipment identifiers, to a trusted application server when a UE tries to register in a visited PLMN. And the second requirement may be receive a notification reply from the trusted application server indicating specific actions to the home PLMN, that is reject UE registration, trigger a SOR command like that. Next slide, please. The third and the last use case under this roaming PLMN is basically subscription based routing to a particular core network. See, basically the users will be categorized under gold category, silver category, bronze category, etc., etc. So based on these categories, there may be a specific visited PLMN which gets planned to process. So accordingly, this particular use case will take the decision which users should be processed under which PLMN. So again, in this diagram, the users will come to the geography 1 from geography 2 as a roaming user, and in the visited PLMN, since there is no subscription exists, it will be forwarded to the home PLMN, and in the home PLMN, they will see whether the users belongs to any particular segment. So in this particular scenario, we have considered UEB and UEC belongs to the segment X. So for these two users, the registration attempt will be forwarded to the mobile network operator 2, where it has been strategized to process these two users under this particular PLMN, whereas the user UE and UED gets processed within the mobile network operator 1 itself. So these kind of strategizing which segment of user should be processed under which PLMN will enable the 5G system to address this issue through this use case. So in the next slide, please. The probable new requirement that comes out from this use case is the 5G system shall be able to support a mechanism for forwarding signaling traffic pertaining to UEs of specific subscribers from their home PLMN to a target PLMN. Example, to enable further handling of those UEs by the target PLMN. The forwarding mechanism shall minimize signaling traffic in the home PLMN. Example, by using efficient means to forward traffic from the selected UEs. So these are the three use cases which was considered for this study under release 19. And as per the latest essay plenary report, the study has been completed 100%, and it has been sent for one-step approval, and probably this gets converted into a technical specification sooner. Thank you, and that's all about the value-added service. And the next item, again, I have to take this item. So this item is on release 19 feasibility study on network sharing aspects. Network sharing, again, network sharing is also a very old and very rock solid feature right from 2G days. But still, again, why we have to study on the same topic, same reason as well. So as you all know, network sharing is basically sharing of RAN and sharing of RAN plus core network entities as well. And basically to utilize or to optimize the deployment needed, that too when 5G kind of scenarios where more and more base stations needs to be deployed, because as and when we go higher in the frequency band, the coverage gets reduced, and because of this we may have to end up deploying more and more towers. And when we deploy more and more towers, there will be a increase in sharing of more and more base stations in certain geographies. So because of this, the network sharing definitely helps. But do we have any issue in that network sharing? That's what we are going to see in this particular thing. So in the past, we have seen two types of configuration, that is the gateway core network, where both RAN as well as the core network entities gets shared across multiple operators. In case of multi-operator core network, it is predominantly the radio which gets shared across multiple operators. Okay, next slide, please. This is the diagram about the network. These are the two architectural options that is supported from the network sharing point of view. The left side talks about the gateway core network, where if you see the E node B in the middle column, the E node B has been shared by both operator A as well as operator B. And also if you see MME, mobility management entity, is also getting shared between operator A and operator B. So that's why it is a gateway, it's a GWCN kind of configuration. On the right side, we have seen MOCN, where the NG-RAN is shared by multiple operators, that is operator A, B, and C. And there is a direct connectivity from this core network to the shared NG-RAN. So this is the MOCN. And a point to be noted is in 5G, at least from 2G till 4G, both MOCN as well as GWCN configurations has been supported. Whereas in 5G, as of today, that is as per the latest release, only the MOCN, 5G MOCN is being supported so far. So here is an opportunity for all of us to study further on how to support GWCN from 5G and beyond. Next slide, please. Basically, as I said earlier, up to release 16, we have both GWN as well as MOCN has been supported. But in 5G, it is only the MOCN is supported and GWCN is not supported. So basically, we can we can study further on what possible use cases that demands GWCN even in 5G and beyond. The one of the key challenge why this particular study has come up is because of this. See, if you see in MOCN, all the shared operator, all the participating operator will have direct connectivity to the shared RAN. So as and when the number of shared RANs increases, the number of direct connectivities also increases, which is posing very challenges for the operator to maintain those direct connectivities. So this particular study has enabled to think whether these direct connectivity can be avoided, but still maintaining the sharing of the RAN. That is the problem statement. Next slide, please. So our around 7 use cases has been considered for this network sharing aspect. This is one particular use case where if you see the operator 1 is a hosting operator where he is sharing the NG-RAN and he is having its own core network. And if you see operator 4 as a sharing agreement with operator 1. So that's why the operator 4 has got a direct N2 connectivity. If you see here, the NG-RAN of operator 1 is having direct connectivity from operator 4 core network as well as operator 1 core network. So these two appears to be as a MOCN configuration. Now, if you see operator 2 and operator 3, they have a roaming agreement with operator 1, but this time it is indirect connectivity. They need not have direct connection with the ORAN. Now, NG-RAN, they have indirect connectivity. That means these two core networks will have connectivity with the OP1 operator 1's core network, which in turn forwards to the NG-RAN because he is having the direct N2 connectivity. So this OP2 and OP3 core network is in a indirect based network sharing. That is what the main agenda of this particular study. Now, because of this, the number of connectivities from the shared participating operator core network to the NG-RAN need not be many. It will be one connectivity to the operator 1 core network, and that core network will have only one N2 connectivity with the NG-RAN. So now in this way, even if more number of RAN nodes which will be under sharing mode, the participating operator will have only one connectivity through which we can handle the we can utilize the benefits of RAN sharing. Next slide, please. Because of this, there can be two possible requirements. The 5G system shall be able to support network sharing with indirect connection between the shared access network and one or more participating operators core network. The second one is the 5G system shall be able to support means for participating operators to provide their operator name to a registered UE for displays to the user. Going forward for all other cases, I will not read out the potential new requirements for each use cases. It has been highlighted. I request you all to please go through that requirements in detail. Next slide, please. Next particular use case is about going forward. All the use cases are from this indirect method of network sharing. And in this particular case, there is a IMS network by both the operator. The operator 1 is a hosting operator where he has shared the NG-RAN, and operator 2 is a participating operator. That means he is going to share the NG-RAN of operator 1, and there will be a one inter-PLMN connectivity between the operator 1 and operator 2. If you see here UE2 of operator 2, that means UE2 has been registered in the operator 2's network. That means for UE2, operator 2 is the home network. So when UE2 wants to have a voice call to the UEN, so to entertain the voice call, the two operator, the inter-PLMN connectivity, they need not share their IMS network, because of this inter-PLMN connectivity, the same operator 2's IMS network can support the voice call when the UE2 wants to have call within the operator 2's network, or when it moves to the operator 1's network. Still, the operator 2's IMS is coming into the picture. If to support this call like UE2 to UEN, operator 1's IMS network need not be utilized. Operator 2's IMS itself can be utilized for this particular use case scenario. Next slide, please. Next slide, please. These are the requirements for that use case. Okay, in this particular case, it is about network access control and mobility between sharing parties. If you see the left side top figure, the UE of the operator 2, here the operator 2 is a participating operator. That means he is going to share the or utilize the base station which has been shared by operator 1 and operator 3. So operator 1 and operator 3 are the hosting operators, and operator 2 is the participating operator. So the UE which has been registered with the participating operator, when it moves from operator 2's 4G coverage area to the either to the operator 3's 5G coverage or operator 1's 5G coverage, the handover should be possible. That support should be enabled, and vice versa. If you see the right side figure, they actually here the UE from the operator 2's 5G coverage, when it moves either to operator 1's 5G coverage or to operator 2's 5G coverage, the handover should be smooth, handover should be supported, and also all call related or service related aspects should be supported. In the bottom figure, when the user is moving from when the UE of operator 2 moves from operator 3's 5G to the operator's 1 5G coverage, the handover and the related call related services has to be continued and supported. So these are the aspects that needs to be supported when there is a indirect inter-PLMN connectivity between the participating operator and the hosting operator should be supported. The next slide talks about the potential new requirements because of these use cases. Next slide, please. Next, these are the requirements. Next slide, please. So, sorry, this slide. So, in this particular case, the international roaming use cases. In this particular case, if you see the operator 1, that is which is in yellow color, which is sharing the NG-RAN, and it has got a core network. So this is a hosting network. Operator 1 is a hosting network, and operator 2 is having a shared core network, has got a connectivity, inter-PLM connectivity with operator 1, and operator 3 is a international operator where it is having a roaming agreement with operator 2. So also agreement or anything with operator 1, and also you need not be aware, but the UE is registered with operator 3. Now that means for UE is a operator 3 subscriber. When the UE comes under the coverage of operator 2, then he will still get the service from the operator 3 via the operator 2, because it's a normal roaming scenario. Now, and imagine when the UE comes under the coverage of operator 1, that is the shared NG-RAN. So here the UE still get the service from the operator 3 via operator 1 and operator 2, because these two have a sharing agreement, and OP2 and OP3 have a roaming agreement. So even in this particular scenario, the user should be able to get service from the operator 3. So this is basically from the international roaming perspective. This particular use case is also has got a potential new requirement, which has been highlighted at the bottom of this slide. Next slide, please. I think next slide is talking about the hosting services. The service hosting environment could be managed by operator 2 in this particular illustration. So this host service either from the cloud service, cloud at the cloud, centralized cloud, or at the edge also. It has been assigned to the operator 2 network. It has been network. Now, since UE of operator 2 is under coverage of operator 1 serving area, so this user should be able to get all the element connected operator 2. Okay, I think emergency call. Next slide, I think there may be some issue. Akash, am I audible?
Yeah, Mahesh, there is some audio cuts at your end.
Hello?
Yeah, Mahesh, there is some audio cuts at your end.
Yeah, sorry. Am I audible now?
Yeah, you are. Maybe you can switch off your video. That might help.
Okay, thank you. Yeah, in this particular use case, it's on emergency call routing. So again, the emergency can also be routed even though the user associated with the participating operator is outside of its coverage area. So in this case, the UE belongs to the participating operator, but now UE has come under the operator who is sharing the NG-RAN. So in this NG-RAN, suppose if this UE initiates a emergency call, that emergency call has to be routed based on the UE's location by the operator 2 to the PSAP. In this particular scenario, the PSAP is well within the area 1. So it is always better to route the call, route the emergency call to the nearest PSAP in case of emergency call. So even in case of indirect MOCN kind of connectivity, the routing of the emergency calls should be supported. Next slide, please. Next slide, please. This is the highlighted new requirements. The last use case on international on the basically on the highways. Next slide, please. Yeah. See, in the highways, these days people are trying to provide coverages all along the highway, and it need not be possible for all the operators to provide coverage by installing towers. So here what happens, some portion of the highway will be covered by some operator, some portion by some other operator, and some portion even by satellite, that is non-terrestrial kind of coverage. So even in this case, the indirect connectivity between the participating operator and the hosted operator should be possible. That's what this particular illustration indicates. I think that's all. In the interest of time, I'm going to stop at this point. Thank you very much. Over to you, Samar.
Thank you, Mahesh. Thank you very much for keeping it very brief, and I know these are very engrossing topics and require much larger derivation. And that's the premise of the next step, that we are going to launch a poll which will give us an insight about that, what is your interest on 3GPP, what is your interest in these study items, and how much and where you want to participate. I would request all of you to poll here. We will be open for some time. Please do poll all the questions based upon your interest. Accordingly, we will reach out to you. You can also reach out to us, connect with the Pritam Bishnoi or connect to any of the speakers, anyone. Yeah, and also, we will have the workshop 2 and 3 as well coming up. So I would request all of you to register for them as well, separately as well. Asif, can we launch the poll, please? So please take your time quickly to answer these questions. We will be having these questions approximately for 15 seconds. So. Asif, we have more questions. Yeah. So it's a multi-select. Please choose accordingly.
So all poll questions will be done.
Okay, thank you. Thank you, Asif. Thank you very much. I hope all of you got enough time to answer to these questions. In case if you couldn't, no worries. We have the expression of interest form being sent out to you. You can always fill your interest and send that back to us. Even not that, you can always reach out to Mr. Bishnoi, Pritam Bishnoi, and he will be very happy to assist you in all possible ways, or any of us, either to me, to Vinay, Jishnu, or Maheshji, or anyone for that matter, they will help you with. Asif, will we have the results also available?
Yes, sir. I can flash one by one for maybe 5 seconds.
Okay. Yeah, that would be helpful. All right. Okay. Fair enough. Right. So thank you very much for these inputs. This is a great insight to us. The people who are interested in study, I would again request to connect with us. We have all the script forums and everything coming up, which will be help us to participate to release 19 and going forward. The people who said they are not interested in these study, they can attend the workshop 2 and workshop 3. They will find something interesting for them. So with that, I would invite Mr. Deendayal Toshniwal, who is with us. He is a My colleague with me, he is helping me in chairing the roadmap committee, and with his able guidance, I'm able to do whatever I am able to do. He has vast experience in the telecom domain, in the wireline and the wireless networks. Currently, he is working as the DDG Network and Technologies, which is the heart of the 3GPP systems and creating all the networks in India. And he's a very modest and go-to person, right? So it's always pleasure working with him. So with that, I would invite him to give his closing remarks, and I want to thank all the speakers and the entire secretary team who has worked very tirelessly to make this event happen. Over to you, sir.
Good afternoon, everyone, and thank you, Dr. Samar, for the kind words. At the outset, I would like to express my deep sense of appreciation and gratitude to all the distinguished speakers for sharing their valuable insights in this first micro workshop in a series of joint micro workshop on advancing 5G towards 6G, which is being organized by DoT and TSDSI, with the objective to disseminate information about 3GPP technology areas and timelines related to Release 19's, mobilize Indian ecosystem to contribute to Release 19 ongoing studies, and to identify and propose any new study to be undertaken as Release 19. This workshop was devoted to the theme on studies related to mobile network studies. My heartfelt gratitude to all those who have attended the workshop and helped to make it such a successful event. As we all know that our visionary leadership in the country desires India to make global lead, to take global lead in the 6th generation wireless technologies. Such workshops will definitely play a key role in that direction and act as a platform to bring academia and industry together in developing indigenous solutions and help in significantly ramping up our contributions at the global stage. Even though India is the world's second largest telecom market, we are nowhere near taking lead in as far as standardization is concerned. We are lagging far behind, and the total number of contributions coming from India is less than 0.5% of the total 3GPP contributions in 2022. So we should strive to increase this number to at least 20% within the next 10 years or so. And the two factors which are in play are the total contributions, contributing members, and their average contributions. We need to grow both these numbers to increase the total contributions coming out of India. As said earlier, the primary goal for today's workshop was to spread awareness about standardization work across the broader telecom ecosystem in the country, so that more and more people join this journey. TSDSI experts have spent considerable time and energy to make this workshop possible, and I congratulate them all for their untiring efforts in giving shape to this series of workshops. In my capacity as co-chair of TSDSI, I thought it would be appropriate and useful to summarize some of the key points which has emerged out of this micro workshop. So the Release 19 study item, energy efficiency as service criteria, which was discussed by Mr. Vinay Srivastava from Reliance Jio, aims at supporting energy efficiency criteria as part of communication service to the users. This will be an important step towards communication services which are cognizant of the energy utilization, enabling well-rounded policies for the future generation wireless networks being defined under 6G. Then another Release 19 study item which was discussed today was on satellite access phase 3 by Jishnu from Tejas Network. From his presentation, we can infer that 3GPP SA1 as part of Release 19 is looking into store and forward operations with discontinuous feeder link for delay tolerant IoT, GNSS independent operations, positioning enhancements for satellite access communications between UEs under the same satellite's coverage. Other two Release 19 study items discussed today were of roaming value-added services and feasibility study on network sharing aspects by Maheshji from Reliance Jio. His presentations deliberated on the challenges for the partners network operators related to the maintenance generated by the interconnection, that is the number of network interfaces between the shared RAN and two or more core networks, especially for a very large number of shared base stations. To minimize such challenges, a study has been initiated on 7 use cases. It covers the gap analysis and tries to define new requirements wherever applicable for these 7 use cases. Hence, it would be prudent to initiate research, development, and standardization efforts in India toward these study items which were discussed today. We encourage each and every one of you to use these workshops effectively and join us in our future endeavors. Standardization work is a collaborative effort, and members will get a chance to work with the best and brightest in the industry. DoT and TSDSI have built a space that is conducive for research work. We have members across startups, academia, MNCs, and the broader Indian industry. Once again, I thank all the participants for their enthusiastic participation and expect that this series of workshops would go a long way in fulfilling our dreams to see India as a major contributor in the global standardization space. I also invite suggestions from all to make this effort more meaningful. With these words, I hand over the floor back to Dr. Samar. Thank you.
Thank you, sir. Thank you very much for your kind words. And as you rightly mentioned, we all invite all the suggestions and the participations from the audience to improve upon us, to make India progress, and to make all of us proud about ourselves, what we are. With that, I would like to thank the entire audience. Their active participation has given us a lot of enthusiasm and courage to continue such effort in the days to come. I want to thank all the speakers who could graciously take out the time to present their valuable insights on the technical topics. I also want to thank Mr. Christopher and Mr. Toshniwal for the kind words and sparing time out of their busy schedules for inaugurating and closing this particular first workshop in this series. And the people who are not very visible, the entire secretariat, the IT team, the team who is very instrumental in making it happen, our Marcom team and everybody. I mean, there is an immense amount of effort which has gone by in making all this entire event happen. I would like to close by saying that this is not the end. This is the start of the work. This is the start of the journey. We have another workshop coming up next week, same time, which will touch upon the other part of the studies related to technology and systems on the release 19. So please dial in, please tune in. Don't forget to register for the workshop too. You will get a link to join that particular workshop. In case of you have any challenges, any queries, please reach out to us. We are always available. And do fill out the expression of interest form and track us on social media platform as well. So with that, thank you once again, and sorry for overshooting the desired time, but I hope it was helpful for all of us. Thank you very much. Thank you very much.
Thank you.
Thank you, everyone. I'm just ending the session now.
Thank you.